Welcome everybody to today's integral. So today we're going to be using the substitution technique. So since this is our first video about the substitution technique, we'll first start with discussing the substitution technique. So what's the goal of the substitution technique? It's basically we're just substituting a part of this integral, then taking the derivative of that part so we could reduce its size, making it easier for us to solve. And at the same time, our main goal is to make it look like something inside our integration table, or basically look like something integrable for us. So let's start with substituting the part inside of this integral. So how do we determine what part should we take? Well, usually you're going to develop this by time, but for now you can know that it's usually this thing inside of a bracket, for example, something inside of square root, the something that is inside something. All right, so here I would like for you to guess what is the part that we're going to take. All right, correct. I believe you guys have guessed x to the power of 3 plus 1, right? So let's take it here to the right, and we'll say u is equal to x to the power of 3 plus 1. Then let's derive u equal, let's derive u basically. So we'll have du over dx, and we'll take the derivative of this side. So we'll have du over dx. What is the differentiation of x cube? It's basically 3 times x. 3 minus 1 is 2, and the 1 disappears, right? So now what do we have in here? We have d of x, we have dx. Let's change the du. Let's make du equal to 3 x squared dx. Alright, now let's substitute the dx. We usually substitute dx, and sometimes we'll use manipulation to substitute some parts inside the u. We will see that in an advanced question. So for now we just substitute dx. So we have dx is equal to du over 3x squared. So basically, let's rewrite our integral. We will have the integral of x to the power of 2. We have u. We know u is equal to x cubed plus 1 to the power of 5 du over 3 to the power of x, 3 times x to the power of 2. Now as you can see over here, we can cancel the x with the x. Then we will have u to the power of 5 du over 3. Well, as you can see over here, we have eliminated all instances of x. This is one other important thing that you have to keep in mind. When we are substituting, we must have only one variable inside the integral. Like we can't have u, z, and x. We can't have u and x. We can't have more than 2 different integrals. So we'll just have u only. Alright, so as you can see over here, u to the power of 5, we know this. It's in the integration table, right? So this is equal to, we can take the 3, which is also 1 over 3 outside. So we'll have 1 over 3 outside, u to the power of 5 plus 1, which is 6, u to the power of 6 over 6. Then we will have 1, or basically u to the power of 6. Now 3 times 6 is 18. But this is not our final answer. You know, we started with x, we have to end with x, right? So we know the value of u. Up here we have u is equal to x to the power of 3 plus 1. X to the power of 3 plus 1 is the value of u. So we can't end up with u. We started with x, we end with x. So let's change the value of u again, and put it back as it was originally. X to the power of 3 plus 1 to the power of 6 over 18, and this is plus c, of course, and this is the final answer of our integral. Thank you for watching. That was Professor Seemo, and this video is part of the integration series where I solve an integral every day, and this series covers integral table, substitution technique, by parts, a higher power of trig techniques, and partial fractions. If you wish to see more videos related to this series, don't hesitate to hit the subscribe button, the like button to share and support this video, and of course you can also share it yourself with your friends and colleagues so everyone could learn. And most importantly, don't forget to hit the bell button to see and get notified when a new video is uploaded. Thank you again. We'll see you in the next video.